So VCS, any idea about this particular version control system and why we are using and why we need to use this particular version control system? So this particular version control system, whatever it is there, so this is a must and should be known by everyone, not only a DevOps engineer, not only a developer or QA engineer. Everyone should know about this version control system and what is the importance of this particular version control system. Okay, so any idea, any guess, what is a version control system and why do we use that? The name itself says version. Any guess?
What, Chandra? Can you
So
repeat once again?
any guess on what is a version control system?
Yeah. I just a brief idea I have, like means which version we are using. Like for example, we have OS versions, right?
Okay.
So in
Yeah.
that way, yeah.
Yeah, got you. Yeah. So somewhat similar. So here, version control system, why we prefer this particular version control systems in our day-to-day life. This is part of everyone's life. Okay. So this particular tool, whatever the tools that come under this VCS version control system, used to track the changes. Okay. So whatever the changes that you are bringing towards a respective file, or whatever the changes that you are bringing towards a directory, okay, over a specific period of time, what you are doing, what are the changes, okay, to track whatever the activities that was happened over that particular file. For example, if I am going to create a respective like demo.json file, so from the time it was getting created, the file, so whatever the activities that I do, like a single space that I place in that particular file, or adding one of a variable, or adding the content into that particular file, so everything will get tracked. Not only that, it is like we can able to track who had done the changes as well, who had made a respective changes towards that particular file. Imagine that for a single file, we are able to track what activities that are going to be happened, or what happened, or who has done that. So this particular version control system is not limited only towards the files. So this is used for the directories, that means of folders, or even at the time of a deployment. Even at the time of a deployments, we used to say that, so this is a release 1.2, release 1.3, or certain things, like as one of person said that the versions of the operating system, yeah, even those, whatever the versioning. For example, today some Java 24 was launched. So for that particular Java 24 also, there is some development activity that will be happen. Right. In that particular development activity, what are the commits that was taken place to develop that Java 24? Right. So all these can be tracked by using a commit IDs. We can able to track what are the changes that was happened towards a folder, or a file, or anything in that respective package. Right. And even this particular version control system is helpful for us to provide the release naming, or the version names, which version that you are releasing towards the market. Okay, the developers are creating the code, everything is fine. So how does the developers know that this is the next version, right? So every release, we will be following a respective versions there. Okay, so whenever we are sending that particular developed code towards the market, let's say I'm using a market, so it means like a play stores, Google Play stores, or app stores, or whatever the web application services, anything. Let me uh, assume that it was a market. Okay, so in the market, if there is any availability, so we will be getting an alert, a new version was released. How we are getting that particular version number there? Who is giving that particular version number? So we can provide that particular version number using these VCS tools. We can generate that particular version numbers automatically using this particular VCS tools, or we can manually provide with whatever the specific numbers that we want. That is also available. Okay, now not only a tracking, even whatever the activity that you save, like you had worked for almost 1 year, that particular work should be stored somewhere, right? A specific space, or you need to take the backup of that particular folder, or whatever the amount of the work that you had done, right? Everything is possible using this particular version control tools. And here we had three types. Here we had three types. This is local version control system. Local version control system. So majorly there are three. Okay, but most probably we will be using the distributed, which we are going to discuss. Okay, so in this VCS, the first one that we need to know is LVCs, that is a local version control system. So what is this particular local version control system? Where do we use this? Okay, local, that means that particular space will be available for only one person. Okay, so anyone had any idea like local host or certain things? Whenever you are developing any of a web application, or whenever you are deploying your application in your local machine, so some people will be letting you know that reach out to localhost colon 8080 or 8081, certain things, right? So what is that particular DNS URL? So why they are saying that? Right, because the application is deployed into that particular local machine, and in that particular local machine the application is available at that particular DNS URL. The same case here, local version control system, in the sense, for example, there is a Pranav. Okay, and this is the first day of his office, and even it is a startup. Okay, and the first day no infrastructure was ready, nothing was there, nothing is there. So there is an office environment, and there is a provided local workspaces and all that, but the infrastructure is in building stage. Okay, but Pranav started his work. Okay, where should he store his work right now? Where should he store his work? That means he will be opening some of a IDE tool like Eclipse or PyCharm or any of a tool for developing the code. Okay, he will be developing the code. Where he will be developing the code? In your local system. In your local system, you will be creating a respective folder. So inside of that particular folder, you will be creating a respective files regarding the development. Okay, or There is a Shiva. Okay, Shiva was recently joined, and he even did not get the access for whatever cloud environments or whatever the resources. Now Shiva was given a task, okay, to execute a respective script or certain things, write a script to do this particular transformation. Now where he should do? He has a laptop. He was provided with a laptop and everything is fine. Where he should do? Right, in the local system, he need to use any of an IDE that was presented and need to create one of a folder and need to store that particular file there. Right? So that is what the local version control systems is. That means your respective work will be stored in your single local machine itself. Whatever the amount of the work that you stored or whatever the amount of the work that you developed, so that will be available only with you until unless you transfer that particular thing towards other using any of a transform medium, right? So these particular things will be like file backups or certain kind of an activities will come under this local version control system. Or we can simply say that if you are downloading any of a folder from the web space, if you are downloading any of installer from a web, so that will be downloaded into your local system. So that is not going to be downloaded towards all of your colleagues, right? If you are downloading a package from the web into your system, that means that particular package will only be downloaded and saved into your local system, right? So that particular package will not be presented in other colleagues or friends workspaces, right? So certain activity will be calling as a local version controls. That means if a respective activity that was done by you, if that is available with only you, or whatever the amount of the work, if that is not reachable by your colleagues, if one of your colleague try to access your code and if he or she not able to do that, and if that particular copy is available only with you, certain kind of a development will be called as local version control system. Okay, so clear? Any questions over this local version control system, regarding local version control system? Any questions on this? Hope it is understand. Can I go for the next? All right. So the next one will be centralized version control system. Centralized version control system. What is this particular centralized version control system? Right? What is this particular centralized version control system? So that means, see, in your centralized version control system, there will be a space. Let me take as a server. Okay, this is a server. Okay, this particular server is available at a respective remote location, not in your local machines. The server space, whatever this particular server space, so this particular thing is available at remote location, not in your local machine or not in your local space. This is somewhere in a remote location. Let me tell you that this is one of a kind of SVN. Okay, SVN tool. Okay, that means similar to our, this is similar to our Git or a GitHub kind of a things. Okay, so this particular server is available at the remote location. Now in this particular remote server, you can store your developed activities. Okay, imagine that this is a storage location, not a complete storage, but this is a space where you can store the files. Okay, this is not a space where you are trying to store some videos or pictures or not certain kinds. This is not certain space. Okay, this is the space where you will try to store the respective files whatever you have developed. Okay, so which is nothing but our development files and all that. Okay, in this particular storage server space, let me create one of a repository. So here in the version control systems we generally used to call repositories. So our respective developers or QA engineers or we or the other people will be working on these repositories concept only. If we are trying to, as a DevOps engineer, if I am trying to develop a Terraform code, I will store my respective code in these particular repositories. I will create one of a repository dedicated towards a Terraform code, and I will store my code there. And if it developers, so they will save their respective development related code in that particular repository, in their specified repository. Now in this particular centralized version control system, the way that you need to work is, so you need to be completely connected over this particular server. Every time you need to be connected towards the respective server. For example, let me say this is a space that you are working. Okay, so if you want to try to store your respective activity in this particular file or in this particular repository, whatever the repository that we are having, if you are trying to store or develop the code in this particular repository, for example, if I am trying to work on a file called some main.tf, that means there is a file called a main.tf. In that particular main.tf I need to work. Okay, whenever you are trying to work in this particular, whenever you are trying to work on this particular centralized version control system, remember this, you should be continuously connected over the network. You should be continuously connected over the network. That means, for example, I can say, yeah, so there is a folder in a space, or let me say that like our Excel, yeah, so the Excel sheet will be there. For example, if there is a team and in that particular team there is a one scrum master who used to track the activities that was doing by the respective team members. Now to track that, and who knows what respective domains, to track that, the scrum master developed an Excel sheet where everyone should reach out towards that particular Excel and need to update that. Okay, so can you update in your local Excel? For example, there is a link that was provided by the scrum master to update your activities in that particular Excel sheet. Will you update in that particular link, or will you update your respective activities in the respective Excel which is available in your local machine? So in which space, if you update, that will be tracked by all of your teammates. What is the location? So one location is, let me, so one is the online, and the other one is the offline tool. So in which the first one is the online link that was provided by your Scrum Master to update your activities, so that everyone can able to see your respective things what you are doing. And the next one is the offline tool, which will be available in your local system and which can only be seen by you. So which is a more preferable one? Which is the most preferable one? Come on. If you want to connect towards this particular online link, what is required? Any guess? If you want to connect towards that particular online link provided for the Excel, what is required initially? Any guess?
Internet network.
Internet. So without the internet, we cannot reach out towards that particular link and see that particular activities, right? But this particular offline, we can open that particular Excel tool and we can do whatever the activities that we want. We don't want any of an internet, right? So this particular online related thing, that means whenever there is an internet or whenever there is a network, then only you can able to do the respective activities, right? So whenever there is a network that was available with you, then only you can do the respective activity. So that is what the principle available with our centralized version control system. That is what the principle that was available with our centralized version control system as well. If you are, whenever you are working on a respective file, whenever you are working on a respective file, you should be continuously connected over the network. You should be continuously connected over the network. Then only your activities will get tracked and updated there. If your network is lost, your work is lost. That is the reason some of our banking projects will only be used this particular centralized version control systems for their privacy. Here, accessing the respective repository or downloading this particular repository is very easy. Downloading the repository or accessing this particular repository is quick and easy, and the commands is also very less. To track the activity, the commands will also be very less. But here, if there is any issue with our server, remember this, if there is any issue with this particular server, if this particular server was lost, if this particular server is lost, your respective entire activity will be gone. There is no backup. Remember that. So this particular server, if there is any issue with this particular server, so our activity will also get affected. If your server is down, you cannot able to reach out towards that particular repository and you cannot update. Remember this, if your server is down, where your repository lies, then the amount of the work that you are doing cannot be updated towards your respective repository. That is one of a disadvantage with respect to centralized version control system, right? So this particular centralized version control system completely works over the network. If the network is lost, the entire activity will not get tracked. Or even, for example, if there is an employee 1 and employee 2, if they want to merge the code at the same time, that is not possible. If the two employees is trying to make a commit at the same time, there we will be getting the conflicts. The merging activity takes time. That is also one of a disadvantage here in the centralized version control system. But what is the advantage of this particular centralized version control system is the security. Security wise, this is the most secured space. That means no one outside of your network can able to track or can able to download your repository. Security wise, the centralized version control system is the best. That means here also the same. See, if you are in that particular network, then only you can able to reach out towards that particular file. If you are outside of that particular network, you cannot able to reach. Right. So due to this kind of a disadvantages, like there will be no backups, there will be a no um for example, yeah. So if there is any network lost, your activity will not be tracked, and there will be a conflict issues when you are doing a merges at the same time, and even the merge will be taken at a certain time. And if the respective build activity is failed, you need to face with respect to the conflicts, right? So all these, due to all of this, today in the market most people are trying to go towards a distributed version control system. Distributed version control system. Today every DevOps engineer, most probably almost a 95% plus people are using this distributed version control system. So what is the difference between that particular centralized version control system and distributed version control system? Let's see that. Let's see the difference. Okay, this is also the same. Let me write here. Yeah. So there will be a repo, remote repo. Okay, so this particular thing is a distributed version control system. Okay, so this particular repository which is available at a respective central space, not the centralized. Okay, I'm saying a central space. That means the space which can able to reach out by all of your team. Okay, the space which can able to reach out by all of your team members will be called as a central space, or the space where you are storing your development activities. Okay, so this particular repository, there are certain tools like a GitHub, Azure Repos, Bitbucket, Mercurial. So a lot of tools out there. We can use any of a tool. Okay, so here the difference between that centralized version control system is the centralized version control system. If you want to work on a centralized version control system, you need to be connected over this particular repository continuously, right? If you want to work on a respective file, you need to be connected over that particular file continuously. But here what the thing is, this particular thing we call as a local repo. That means first thing what we will be doing is we will be doing a cloning activity. A cloning activity will be done from our remote space towards our local space. Cloning activity, that means taking the exact copy of that particular object. Cloning, taking the copy of that particular object or item or whatever we want. Right here from the remote space, I will be doing a cloning of that particular repository. That means whatever the repository that was there, I will make a clone into my local machine. Okay, so I will make a clone of that particular repository into my local machine, which is nothing but will be in the format of a folder. That means a folder will be available in your local machine. Okay, the remote repository which is cloned into your local machine will be called as a local repo. That particular local repo will be in the format of a folder. Now, see, whenever you are making a respective, where is this? See, whenever you are making a respective cloning, only then you need to be in contact with that particular repository with the network. Whenever you are making a cloning activity or updating your respective remote repository, okay, once your development is finished, and if you want to update this particular remote location repository, then you should be connected over the network. Rest of the time, no, not required. But in our centralized version control system, every single minute or every single time we need to be in contact with that particular repository in the network itself. But here, whenever you are doing a cloning, you need to connect towards that particular network and you need to do the clone, so that the local copy will be available in your local machine. Okay, so from this particular local repository, from this particular what we call repository or a working directory, anything. Okay, so from here I will open a respective IDE tool, so it might be something like a PyCharm or anything. Okay, so I will be developing my code, which is nothing but working copy. Okay, so this particular local repository which is in the format of a folder, I will open that particular folder inside of an IDE tools. That means either a PyCharm or any other tools. I will open in that particular tools. So which will be acting as a working copy. Remember this, working copy. So here you don't want to be connected towards the network. No need of the internet. Okay, for example, just make a guess. Okay, in my local system the internet was down, my file was available with me, or imagine there is a text file in the folder, there is a text file in the folder, and in that particular text file I need to update certain content. I need to update certain content in that particular text file which is available in my local laptop or local machine. So do I need to wait until the internet is back, or can I open the notepad or notepad plus plus or any other tool to update that particular text file? What can I do? Come on. See, there is a file in my local machine, a text file in my local machine. That particular text file, in that particular text file, I need to update the content. Okay. And by the time when I update that particular content, the internet was down. So should I wait until the internet is back, or can I go towards the other tools like a notepad or notepad plus plus or some other tools where I can edit that particular text file? What can I do? Should I wait or should I continue my work with the other tools? Any answer from you? So am I audible?
Yeah, you're audible. We can continue with the existing tools that we have.
Right. So we can, instead of waiting for the internet, I can open that particular text file in some of a notepad or notepad plus plus, and I can update that particular file. Right. Similarly, here also the same. You no need to be in contact with the network. So why? Because you had already taken a respective local copy here. You have already taken a respective local copy. You no need to wait for the network until the internet is back. Open one of a PyCharm or whatever the respective IDEs that you had, Visual Studio Code, or any of the tools. Open that and work on your development activities. Work on your development activities. Like for example, if you want to develop some Python file, update that or create that particular Python file or Java file, right? So and make a text and make a test in your local machine. Make a test in that particular ID by running Java compile or Python build commands. So once your development is ready, right? Once your development is ready, make a push your respective working copy towards this particular local repo. Remember this. Make a push a respective copy towards this particular local repo once your development is ready. Until then, you no need to be in contact with that particular network. This is very important. Okay, so once the development is done, move your respective development activity towards the local repo. And if you want to update your remote repository from your local repo, and if you want to update your remote repository from your local repo, now you need to establish the networking part. So once you move your development activity towards your local repo, then establish the networking part and push the respective changes towards the remote location. So you no need to be in contact with the network every time that you work. Whenever you are downloading or whenever you are importing your work, whenever you are importing your work from the remote location, you need to be in contact with the network. And whenever you are updating your respective work with the remote location, then you need to establish or be in that particular network two times. One is whenever you are importing, you need to be in that particular network, and whenever you are exporting your development activities, then you need to be in that particular network. But in our centralized version control system, that is not the case. You should be every time in contact with the network. If your internet is down, so you cannot work on that, or if that particular server is down, you cannot work on that. See, here also there is a cases. Here also there is a case. Sometimes the GitHub, whatever the GitHub that was installed in your managed on your personal servers, it might get down. See, this particular remote repository can also be down, but here the backup is there. Here the backup is there. Where is the backup here? That is nothing but our local repo, local repository. Our work is not completely lost. If that particular remote location is lost, even then your work is saved in your local machine. That is what the advantage when compared to our centralized version control system, the distributed version control system has. If your remote server is down, even then you can work on your respective activities. Even then you can work on your activities because you had this particular local repo, which is nothing but a local copy. You already had a local copy, so that your work is not completely lost. But in our centralized version control system, where you need to be in contact with that particular repository every time, and where you cannot able to take the copy of that particular remote server repository, that particular server is lost, entire your work is down. No backups there. But here there is a backup in the form of of our local repository. In the form of our local repository, there is a backup. That is what one of an advantage here. The advantage here is there is a backup in the form of local repository, even if our remote repository was lost. And the other thing is n number of a people can make the updates at the same time. Remember this. N number, I'm not saying a exact figure. N number of a people can make the updates towards the code at the same time. No issues there. But in our centralized version control system, we should wait until the other people complete it. But here you can make n number of a commits. You can do n number of a people at a time the updates. Or even the respective history, which is in the form of a tree, listed trees. We can track where is the exact issue is. If there is any of a conflict that was happened in the form of a code merge, we can track that using that particular tree history. Backup is there. You can do the development updates at the same time without any conflicts. N number of a people can work on that. Only the part is the security. If you are okay with the security wise, the distributed version control system has whatever you want. And the security also, that's fine. So we will be having a private repositories and a public repositories as well. Again, the repositories are of a two kinds again. One is a private repository and the other is a public repository. So private repository means if you are belonging towards that particular organization, only that particular organization people will able to reach out towards that remote repository. But public repository means any one of a person can able to reach out towards your respective repository. If someone knows your repository name, they can able to reach out towards your respective repository, right? So that is what a distributed version control system and a centralized version control system is. Okay, so for this particular distributed version control system, we are going to work on a Git. We are going to work on a Git. So Git consoles we are going to see on a Git and all that particular stuff. So in a distributed version control systems, we had a certain tools like a Git, Mercurial, fossils. Certain tools are there in a distributed version control system. Here in our centralized version control system, we had a TFS, SVN, certain tools here in a centralized version control system, right? Hope that is clear. Any questions up to here on the version control system? So the version control system is of three types: local version control system, centralized version control system, and a distributed version control system, right? Where local version control system will be used by only the single person. If you want to be a part of a team, if you want your work to be collaborative with your team as well, then the second and the third type is suitable. And where distributed version control system has somewhat more advantage when compared to our centralized version control system, right? So clear over this version control system, the types. What are the types of a version control system types, and why we are doing this particular version control system, why we are preferring this distributed version control system? Clear? Or any questions? Can someone answer?
Yes,
Yeah,
all clear.
it's fine. Yeah.
Yep. Right. I'm just holding it here today. And for tomorrow, make sure that you are all ready with the Git installed on your machines. So Git install Windows. Just go for this. Git install the Windows and go for the downloads and download whatever the respective plugin that you want based upon your respective operating system. If you are using a Mac, just go for this, or if you are going for the Windows, make a download on this. And here as well, 64-bit standard installer. I'm just going on this, downloading the respective package. Okay, by tomorrow make sure that you are coming with this particular kit installed. Okay, and yeah, after this particular download was done, make sure that you install this particular installer. Just go for this, just that is just a .exe file. I'm just going for the installation of this. So whatever the previous that is getting removed. And tomorrow we will see on a detail how to convert a folder into a Git repository, how to do that. Each and every topic will be dealt tomorrow. Okay, don't miss that. Today we just had what is a version control system, how many types of a version control systems that we had, and among that three, why we need to pick up the respective distributed version control system only. Okay, once the installation is done, just go for your command prompt and just check git space hyphen hyphen version, so that it should show what git version that you had installed. Okay, any questions on today's part? So as part of our distributed version control system, right? So yesterday we thought of like there will be a tools like Git, Mercurial, Fossils, right? So among these three also most preferably we used to work on Git, right? So how many of you are aware of this particular Git? Anytime did you get a chance to work on this particular Git anywhere in your graduation or somewhere?
No.
Okay, fine.
Yes.
So okay. So first we will just see on the architecture end what is a Git architecture and how the flow will be happen. So how the file transformations, how the history of a file, and how the changes of a file is recorded. As you said that distributed version control system is having one of an advantage that we can work in the offline mode as well, right? So let's see that. So the first, let me check, yeah. So imagine this is a remote repository, so which is available at a space, something tools like GitHub, Azure Repos, Bitbucket, and there are a lot. Okay, so these particular tools like a GitHub, Azure repositories, or Bitbucket, these will be called as a warehouses. Remember that. So the GitHub and all that particular thing will be called as a warehouses or the hubs to store our repositories, right? The hub in the sense like the space where we used to store a certain data or a things or an objects, right? Similar case, the remote repository which we are going to create, I will show you that as well. So the remote repository which we are going to create will be created in a Git warehouses like GitHub, Azure repositories, or the respective bit bucket. Okay, so let's see that a repository, a remote repository is available, and as I said that if you want to get the code or an application code or the respective data from this particular remote repository towards your respective local system, which we call as a local repo, right? So whenever we are making a clone, whenever I am making a clone, so this particular thing should be connected towards the network. Okay, whenever I am making a clone, that means the first time when I am reaching out towards that remote repository, the first time when I am taking a copy of that particular remote repository, I should do the cloning activity. So one time is fine in your local machine. Okay, taking the cloning, taking the cloning of a repository is fine for one time in a local mission. No need to do the frequent clones whenever you work on that. Single clone is fine. Okay, and later whenever you do a respective cloning, so this will be available as a local repo. After you are doing a cloning, your respective activity will be available as a local repository. So what is this particular repository? Why we are calling this particular thing as a repository? Okay, whenever we are seeing this particular repository, it looks like a normal folder which we see in our local systems, right? So whenever we see that, it looks like a normal folder only, but why we are calling that as a local repository? What is the difference between our folder, our own folder, and the repository? We will see that once this architecture is done. Okay, so after this particular local repository, we will be having a staging area. We will be having a staging area. So this is not like a physical location or something like that. This is just the status of your repository. Okay, and after this particular staging area, we will be having a working directory. So this is the place, where we are working. This is the place where we need to work. Okay, first thing is you need to make, you need to be have, see, today is your first day, and your project has a number of repositories, but your work start on a specific repository, and you are allocated with one of your respective machine. All good, and your respective team lead or a colleague said that make a copy of this particular repository into your local machine to start working on that. At the first time, you should have the URL of this particular repository. For the first time, you should have the URL of this particular repository, and to make a cloning of this particular repository, you should have the permissions. So at least you should have some read access. Okay, so if you want to get the copy of your remote repository into your local machine, the first thing you need to check is whether you are having a respective access towards that particular repository or not. So whatever the remote repository which was available in certain space, something like at the GitHub or something like at Azure repositories. Okay, if your repository is available at Azure Repos or a GitHub, first thing you need to be make sure is that you are having access to clone that particular repository. Once you get the access, you can make a clone. Clone means you are taking the copy. You are taking the copy of that particular remote repository, the exact copy of that particular remote repository into your local machine or any of other virtualized machines. Generally, we used to work on our local machines. Sometimes we will be working on virtualized machines. That also we will see in further sessions. But let's take first at a local machine. Okay, I had cloned my remote repository into my local machine, which is called as a local repo. And this particular local repo will be similar towards a folder only. But why we call this as a repositories is I will show you that the visualized. Okay, and later this particular local repository will be having certain tracking attributes, certain tracking files will be there. Okay, this particular local repository, whenever we had cloned this particular repository, the local repository will be having a certain tracking activities. That particular tracking activities will be come under this staging area. Okay, so whatever the amount of the work that you do towards a files, all that should be first recorded in this staging area. Okay, and even up like even before you clone this particular repository, what is the history of this particular repository, that will also be there in this particular staging area. I will show you that. Okay, and later once I open this particular folder in any of an IDE, in any of a tools like Visual Studio Code or Visual Studio or a PyCharm or Eclipse, any of a tool. Okay, so once I open this local repository in a tool in the offline, that means in my local machine, that particular activity will be called as a working directory. Okay, so in this particular working directory, you will open the file. If there is any requirement to change the values or to change the code, you will make the respective changes towards that particular files. And your target is you need to send the data towards this particular remote location. Your respective target should be after you are working on a respective files or an activity, you should save your work at a remote location. So how this particular travel is happening is, first thing is, once you make a respective changes or the development activities, so you will make a respective command called git add. Remember this. So you will be making a git add command. So once you done a git add command, whatever the amount of the work that you had done, that will be transferred here, that will be recorded in this particular staging area. Okay, once your work reached out towards this particular staging area, again to send your respective work towards a local repository, we need to make a git commit. Remember this. A git commit, so which will help us to record what are the changes that was happened, who has done this particular change, and what are the changes, which files get changed. Everything is recorded with this particular git commit command. Whenever you are given with this particular git command, automatically a commit id will get generated. Remember this. Whenever you are given with a git commit command, immediately a commit ID will get generated, and that particular git commit ID, the commit ID which was generated, will be having all the details regarding, okay, this particular file has a change and this was done by this particular user. So all that particular history will be there in that git commit ID. Okay, once your respective development activity reached out towards a local repository, now your task should be moving your respective work from your local to remote location. So how you need to do this is using using push command. Okay, so using git push, you are pushing your respective activities from your local repository towards a remote location. So before you are trying to do this particular git push, that means you are pushing the amount of the work that you had done towards your remote location. Before you are doing, make sure that you are connected towards a network, make sure that you established a network connection, right? I will show you that particular comments, what are the comments that we will be using and all that. Okay, so this is the architecture. First thing is, make sure that you are having one of a remote repository, and from that, so no one, so you can directly go. For example, as a DevOps engineer, I will be not having any of a major development activities. Sometimes it is just a value, sometimes it is just a value small. Instead of a 1.1.0, I should make it 1.2.0. Only that change was there. Okay, if that particular change also you can go and do in this way, or sometimes some people what they will be doing is directly they will make the changes at a remote location. The people who are having a right permissions, so they will be directly making the changes at the remote location, but don't ever follow that. Okay, don't make any of the changes directly at the remote location. The best way is this: cloning the repository into your local repo and making the respective changes at a working directory and pushing it back towards our remote location. Okay, this is the basic architecture of the git flow. Along with this, we had a lot of other activities that we need to know about a git flow. What is the commits, what is an history, what is a rebase, what is a merge conflicts, all that we are going to discuss now. Okay, clear here? Any questions here? So are you clear over the flow, how your respective files will be transferred, or any
Okay,
questions
if
over
we do
here?
it if we do it directly in the repository, right? What we miss generally, I mean, let's say if we don't have a requirement such to, I mean, small changes in that. So let's say we just going over there and editing the file and doing the changes and
Mhm,
simply just saving there.
mhm.
So what we miss generally, Chandra, I mean,
Generally
rather
we
than
will be,
just taking into
yeah,
local.
yeah, generally we will be missing a tracking of that particular activity. Okay, so if you directly go and make a change at the remote location, even there you will be having a commit ID get generated. Okay, but what the issue is, we as a DevOps engineers, streamline this particular flow. We will be making the developers habituated towards this particular flow. Okay, we will set this particular flow. Okay, you need to do this, you need to do this is a branching terminology, these are the securities that you needs to follow, all that we will set. Okay, we will set that particular procedure towards the developers, and if we go and directly do the activity at a remote location, that is not a good example, right? Only for that thing we will follow this. And the other thing is, if you are making a changes directly at a remote location, in which particular branch you are going to make that. Generally in our repositories we will be having a branches. So in which branch you will make that? For example, you had an activity to make a change in a development branch, so you will go and make it there, right? So after some days, where does this particular merge comes from? Where does this particular commit comes from? The commit was directly happened at a development branch. The commit was directly happened at a development branch. There is no other branch created and make a respective development, and it was not merged into the respective development branch, right? So we are having this like trees. History tree will be there, where that particular tree will record, okay, this particular data comes from this branch. So this is the code that was get merged into the development branch from this particular feature branches. Like that, we will be having a listed tree there. If you are directly going and making a change there, so by seeing you, the other people will also follow the same, right? Just to avoid that particular things, we will also follow in the same way. Or else we had a feasibility to change if it is a small value, and if you want to change that particular small value, instead of making a commits, you can make that happen using our pipelines as well. I will show you that as well. Okay, if it is a very small change, no need to make repository change, keep it like that. Make a change when you are running the CI/CD pipelines. Okay, both ways we can do that. Clear? Or
Yes. Yes. Thank you.
so anything from anyone?
Chandra,
Yeah.
see, you're saying that only from we create from the local repo and we will git push and we will commit, right? Git add and git push and git commit.
Yeah.
See, if there in the real time scenario, if there are multiple people are working on the multiple people are working on the same file and they are pushing those things, how can we know which one is the updated one?
Got you. Got you. Right. So here, if for example 5 people are working on a same repository, if 5 people are working on a same repository, so they will be creating a separate branches. They will not work on the same branch. They will be creating different branches. That is one of a activity that everyone should follow. One thing is, for example, 5 people will create 5 new branches. 5 new branches. I will show you that. So I'll just go for the other. All right. See here. For example, in your repositories, everyone will follow the same. Okay. In your repositories, majorly we need to focus on two kinds of a branches. One is main or master. One of the branch will be called as a main or master, depends upon our version control system that we use. Okay, and from here we will be creating a development branch initially. Okay, initial step at the first development phase, we will be doing this. We will create a development branch from our main branch. Okay, so from here, so this particular development branch will be used as is like a development activities related thing. Okay, so from here, as you mentioned, 5 people, let me take 5 people need to work on this particular branch. That means in this particular branch there are certain files where that particular 5 people need to work. Okay, so this particular 5 people, definitely there will be a work item allocated, right, using a Jira or something like that to track their activities, what they are doing. A Jira or certain things will get generated. So from here what they will be doing is they will be creating a branches called feature branches. Okay, feature branches development. See, I'm just giving here developer 1, and next one more person, developer 2, same like feature slash developer 2. Like this, each and every developer will create a respective feature branches and they will work on that particular directory. And as you ask me that if both the people are working on a same file, if both the people are working on a same file, okay, for example this particular developer, let me take a respective file name called xyz.json and the same file here, right? So here if this particular developer 1 is making a change at line number 678, okay, if this particular is making a change at 6, 7 and 8, and our respective developer 2 is making a change at, I will just make the same line here, 8, 9, 10. Okay, initially whenever these two people make a copy or generated their feature branches, they will be having a same code. Rest of the lines, for example 1, 2, 3, 4, 5, and rest whatever the lines that was available after 8, everything will be the same. Here also the same, 1 to 7, later 11, and all that will be same. Okay, here the first developer make a changes at 6, 7, 8. Okay, and the developer 1 finished his or her work before the developer 2 completes. Okay, what this particular developer 1 will be doing is this particular developer 1 will make a merge towards this particular development branch, will make a merge. Remember this particular developer 1 will make a match because this developer 1's activity was completed before the developer 2 completes, and the development branch of a file called xyz.json gets updated. Okay, xyz.json gets updated with the latest activities or the file that was updated with this developer 1 changes. Now before this particular developer 2 makes a respective merge, okay, before this particular developer 2 makes a merge, this particular developer should undergo with git fetch. Okay, this particular developer 2 should be taken a command called git fetch. Okay, so that particular git fetch will give you here for the developer 2, that particular git fetch command will give, okay, these are the latest changes that was brought to developer branch towards this particular xyz.json file. So that whenever that particular git fetch gives us, okay, whatever the inputs, whatever the updated file for xyz.json, so there we can perform git merge into your local machine. Okay, into your local machine. After you are seeing git fetch, it will show you what are the history that gets updated, and if you are fine with that particular history, you can make a git merge there. But your work which was happened up to then, it will not overwritten. It will not overwritten. Those lines will just added. Whatever the lines 6, 7, 8 which was developed by the developer 1, those particular lines will also added into your file where you are working. And 6, 7, 8, right? And yours one is you are making a change at 8, 9, 10. So whenever you make that particular git fetch and merge thing, so your 8, 9, 10 will come as 9, 10, 11 if you merge them. Okay, now your respective file, after you are making a respective changes, your respective file is having 6, 7, 8, 9, 10, all the 6 lines in your branch. In your branch where this particular xyz.json is having, all the 6 lines was there. Now you will make a merge towards this particular development branch, and this particular merge we will call as a pull request. Okay, this particular merge from one branch to the another branch, we will make a merge activity that we call as a pull request. Okay, once your respective file was updated, once your respective branch is updated in a specific file, you will raise a PR towards the respective standard branch, right? So that there will be no conflicts. If both the developers are working, for example, if the developer 1 is working on xyz.json and if the developer 2 is working on abc.json, no conflicts will be there, right? Clear? Hello.
Sure.
Yeah, no worries. So it might be somewhat confused here. So whenever I am working on the respective branches and all that, it will be easy, very easy. Respective activity is very easy. It is a bit early, that's it. Okay, so we had this particular working session as well, no worries. Okay.
Yeah, Chandra, I have a one doubt here.
Okay,
Like branch means like change set or any
can you come again? Branch means
branch means change set number or any another like I
no,
have
no,
a
no.
doubt like branch means like change set number or any another.
It's not a chain set, it is just a copy of your folder only.
Okay, like
Okay,
means JS folder like HTML folder
yeah,
that type only, right?
only that particular folder.
Like hmm,
For
like
example,
same. Hmm,
yeah, see, for example, you are having a folder. Okay, so that particular folder
okay.
need to be split among 10 people. Okay, if the 10 people are working on a same folder means definitely there will be a uh, concept of conflicts there. If 10 people are working on a
Hmm,
same folder at a time, there will be a conflicts, merge conflicts will be there. So instead of that,
hmm,
what we will be doing is branching terminology. That means from that particular folder we will create another folder. Just the naming just for tracking of your activities, the terminology change. That's it. Just for, see, for that particular 10 people, we will create a 10 branches. That means you 10 people will be having a new tracking IDs. Simple thing is new tracking IDs instead of overlapping all their works. Instead of overlapping all their works, each person will be having their own tracking ID. Simple thing is that. Okay.
Okay.
Let me
Yeah.
show you. So it will just easy for you whenever I show with a practical session here. Okay. It is very
Yeah.
easy.
Okay, sir.
Okay. See, first thing is, let me go here. So as I said that I required a remote repository, local repository, and staging working directory, right? So for example, right now I don't have any of a remote repository right now, but I need to create, see, first I need to create a local repository in my local machine, and I need to work on that particular local repository. Later, once my development, remember this, what I'm saying. Right now, I am not having any of a remote repositories. What I will do is I will create a local repository. I will create a local repository in my local machine directly. And after making that repository gets created, I will work on that particular repository. And if everything is fine, then I will create a remote repository and I will update my respective development activity towards a remote repository. Okay, let's see that. That is a very basic one. Instead of directly we start with the remote repositories, we will first start with the local repositories, and we will see the basic level of our Git flow. Okay, let's see that. For example, see, I'm just going here, I'm just creating one of a folder. As I said, repository is similar to our folders. Repository is similar to our folder structure. That's it. I'm just creating one of a new folder. So this particular folder I am giving VRIT some 7 p.m. The folder name I was given here. Okay, and to work on this particular folder, now, first thing that I need to do is I need to convert this particular repos. I need to convert this particular empty folder. This particular empty folder, I need to convert it into a repository. My first task is that this is an empty folder. My respective thing is to convert this particular empty folder into a repository. How we will do that? Let's see. See, empty folder, nothing. Empty folder, nothing was there. Even I will just go for the view, hidden items, nothing. In the hidden items also nothing is there, right? Now I will just open one of a tool, any of a like IDE. I am just going to use a Visual Studio Code. Okay, let me open that particular folder. So which is on a desktop. This is our folder. Okay, so this particular folder, see, empty one, empty folder. Now the first thing, see, the respective path also, make sure. Some people will be making a wrong at this the execution of the git commands at a wrong path. Remember this, the path should be directed towards your folder path. See, the path should be the path of your folder. Some people will be directly executing it at a desktop, or some people will be executing that particular git commands, the execution of.
Chandra, could you show me once again how you get that folder?
Sure. For example, see this, I'm just deleting this. I'm just going for my I'm just giving a right click, going for the new and empty
Hello?
folder. That's it. Hello. Can you hear me?
Hello.
Can you guys hear me?
Yes, Chandra, you're good. Your voice is good.
Okay. See, I just created this particular empty folder. Okay, just for right click, give the new, that's it. No other technical terms here. Okay, once an empty folder gets created, I'm just going into one of it. ID.
Chandra, sorry to disturb you.
Yeah,
Yeah, could you show me that visual show you how you get that folder?
no, that's what I'm showing. Let me open this. Okay, let me open a Visual Studio Code. Okay, so here in the file session, open the folder. See here, file, open the folder. I'm just navigating towards a desktop. On the desktop, there is an empty folder called VRIT 7 PM. I selected that and select the folder.
Okay.
That's it. Okay.
Okay, got it.
And yeah, I'm just giving here the select called the toggle panel, which will be enabling me the bottom taskbar. Okay. This particular thing in a Visual Studio Code. Okay. And here, this particular terminal should be navigated, should be pointed out towards the path of my directory. Some people will not see, some people will be executing the git commands at this particular directory. Some people by default they will execute at this particular directory. Remember this, whenever you are executing, whenever you are running a git commands, you should be at the path of your folder. That's it. If you are outside of your folder, then the git commands will not work. Remember this. Most of the people I see, they will be executing the git commands outside of the directory. Make sure that you are executing the git commands inside of your folder. Okay, now this is an empty folder, nothing was there. This is an empty folder, nothing is there. And see here, there is no trackings, nothing, all zeros, zeros. See, all zeros, nothing is there, and this is an empty folder. Now this particular empty folder should be converted as a git repository. An empty folder or a folder with a certain contents which is not a repository earlier, or a folder which is having certain contents which is not a repository earlier, if you want to convert that particular folder into a git repositories, the command that you need to give is a git init, git initialization. Okay, this particular git initialization will generate a git folder inside of your whatever the folder that you had. Okay, this git init will create a .git folder in your folder which you created earlier, and that particular .git folder is very important. If you delete that particular .git folder after you are making a development activities, all of your history is lost. You should not touch that particular .git folder. I'll show you that. See here, git init, I'm just giving an enter. See, initialize an empty git repository. See, initialize an empty git repository at VRIT 7 PM our respective folder, and later it is given some .git. Here, do I see that .git folder here? Do I see the .git folder here? Anyone?
Yes.
No, I am asking, do you see the .git folder here? Do you see the
Not yet.
.git? You are not able to see, right? But see, I am just going into my desktop. I'm going into my desktop in my local machine desktop. And where is my folder? This is my respective folder. I'm going here. See here. If you remove this in the view option, if you remove the hidden items, you will not able to see that. If you make a check of these hidden items also, then you will be able to see this .git folder. Remember remember this particular .git folder is always in a hidden mode. The .git folder, any repository, even it is a centralized or even if it is a distributed, if you are using an Azure repos, if you are using a GitHub, if you are using a Bitbucket, anything is fine if you are following a git commands. Definitely that either a remote repository or a local repository will be having this particular .git folder in a hidden mode. It is not visual always. Always the .git folder will be in the hidden mode. That's it. Okay, let me go inside of this .git. What will be there inside of this particular .git? I'm just going here. See, there are some of it folders, subfolders that was created. There is some of a subfolders that was created and some files. And see, let me go back to my Visual Studio. Earlier, whenever I show you at this particular bottom, all are zeros. All are zeros. But right now, see what it is saying. Let me. Oh, expand is not possible here. Okay, see what do you see here? We are at 7 p.m. Git, and after that it was master checkout branch. That means a branch called master was generated with this particular command, right? So it did not, where is this? Yeah, it did not create directly a development branch. An empty folder or a folder with a certain content, if that particular folder is converted into a repository, if a folder is converted into a repository, right, immediately your work will be saved onto this main or master branch. Immediately, once your folder is converted into a repository, your work will be saved into this main or a master branch. It is not directly creating a development branch. It is directly creating main or a master branch. From this particular main or a master branch, you need to create a development branch and you need to work there. And later, if your development branch has a stable code, you need to raise a pull request again towards this master branch to keep the stable code safe and secure for a future activities, in which we call business continuity plan, BCP, business continuity plan. Or even we are going to soon we are going to see hot fixes, bug fixes and all there also you will know the importance of this merging the code from development branch towards a master branch. Okay, this is too early and you feel some difficulty, no worries, just we will just focus on converting our folder into a repository that we had done, and we see a .git folder in a hidden items, and later we will see how the trackings will be happen here in this particular folders. See here, there is a reference folder inside of my git folder. There is a reference folders. See, inside of this particular reference, let me go towards this heads, nothing, too early, tags, nothing. See, all are empty, and hooks, so these are the commands. See, merges, so all these are some pre-written methods, so we should not touch all this. Let me go back. All right, packages, config, let me go here. Okay, so see, all these particular values will get updated after we are making certain changes towards a folder. Unnamed repository, edit the file description to the name, nothing is there. Now head will be there. See, there is a certain value here. See what this is saying the head, the reference towards the heads call the master. Master is nothing but my branch. Remember this. If you are confused on which branch that you are working on, if you are confused, see, if you are using certain IDs called the Visual Studio Code or Eclipse, by default you can able to see the branch here, no issue. But if you are using some command prompts, for example, you can directly run inside of the command prompt also you can run that particular git commands. At that particular point of time, if you are not sure, if you are not sure on which branch that you are running the git commands, so you can go into that particular repository .git folder and the respective head file. So this particular head file continuously lets you know that at which branch that you are pointed to, at which branch that you are pointed to. So let me give it here. See, there is a master. Okay, I will create a one more branch called the development from this master. Let me click on this. See here, a pop-up was open here. No worries, there is a git command also to create another branch from the existing branch. I will show you, but this is too early. I'm just showing in a visualized manner. I'm just clicking on this master. This particular toggle was enabled. See here, create a new branch. I'm just selecting on that. I'm just giving development. Sorry, your head reference was in open. That's why that error is there. So create a new branch from development, giving an enter. Let's see here. Let me refresh. This is let me close and open this Visual Studio Code. Right. Okay, this is not getting created. I will just create it here, okay, with the command. So git. So to create a branch, remember this, to create a branch, git branch and your branch name which you want to create. I'm just giving a development branch. See, the command to create a new branch, git branch, the respective branch name that you want to create, and later the source branch, the source branch from which your branch should get created. I'm just giving here the master. Okay, this is the source branch and this is the destination branch. Not a valid. Okay, wait, let me take it here. So on a branch master, no commit yet. Okay, so here it is showing that there is no commits that was happening towards a master branch. That is the reason we are not able to create a new branch here. Okay, let me do that.
Chandra, could you raise your font so we can able to clearly see
That's
your screen?
okay. That's what here in this particular Visual Studio it is not possible. Okay.
Overall thing, your screen is
Let me. That's okay. Let me execute the commands in command prompt. So this you can visualize. Fine, right? This is fine.
yeah.
Okay. So let me go to this particular path. Okay, now git status, I'm just checking on which particular branch and what activities that was there in my repository using the command called a git status. See, no on right now I am on a master branch and no commits at, nothing to commit, create or copy the files, nothing was there. Okay, now what I will do is I will just make a commit here. I will just create a one of a new branch here. Okay, I will just create one of a new file here. Let me do
Or
it
do
with
we need to create a file in this master branch, and after
what.
committing that, we can create a new branch?
Yeah, that is also possible. But if you are making it from your remote repository, if you are directly doing at a remote repository, no files are required. Directly that particular remote repository will be initialized. Okay.
Okay. Okay.
But here in our local repository, it is throwing that.
Got it.
Okay. What I will do is we had another one. So git checkout -b refers to the branch. Okay. My respective new branch development. Switch it towards a new branch called development. Let me show you that here. See, on a development branch. So right now you had switched over towards a development branch. See here. Earlier you were with master. Right now I'll just open this particular header as well. See, earlier it was shown something like a master, but right now it is development because you are currently pointing out towards a development branch. That is the reason. Okay, see here, even when I give certain things like a git status, after I have given this git checkout -b refers towards create a new branch with this particular name, create a new branch with this particular name and check out, that means change towards that particular branch. Remember this, git checkout -b development refers to create a new branch called the development and make a change in the branch that you are working, immediately move towards a new branch. That is this particular thing. For example, I will just move towards a older one, git checkout master. See here, git checkout master. The master was not a, what is that? Right. See, this is the issues that we get if we are directly doing it in a local, right? So there is no tracking over this particular which branch that we are working on, right? All right, I'll just clear this to avoid the confusion. So git checkout right now I was at a development, git checkout -b and the branch name. Switch it towards a new branch. The same, it is traveling. That means it is traveling. See, from one branch to the another branch, it is traveling unless you make the commits and you make the activities into the merge. You will not have a proper tracking activities here. See, today what we did is I had directly created a local repository. How did I create that particular local repository? I have created an empty folder, and after creating that particular empty folder, then I have given a git command called git init. That means the git initialization I had given. When I provided that particular git init at this particular path of my local repo, immediately a .git folder was get added into this empty folder. That particular .git folder is used for tracking the branches, tracking the history, all the things, right? Right now what happens is there is no prior tracking here. That means we are not having any of a files here in the references. See, reference headers. See, whatever the headers and all these are not having. Whatever the tags or the heads, all are empty. Why? Because we have created this particular local repository in our local itself. There is no pointed towards a remote area, right? So that is the reason we don't have any of a header references and all that. That is the reason we are getting this kind of an errors while creating a new branch from the existing branch. We are getting this kind of an errors. If you are already having a remote repository available, the creation of a new branch is very easy. Git checkout whatever the branch name that you want and later the source branch. The simple command, that's it. But here we don't have any prior tracking references. That is the reason here the branch names keep on changing. Got it? Any confusion anywhere? So clear your questions here. This is a somewhat, if it's new to you, definitely it will be somewhat a confusing thing. Let me know that.
What is the command for creating a new branch?
New branch is git checkout and the respective branch which you want to create, and later the source branch. That means from which branch you want to create a new branch. From which branch you want to create a new branch. For that particular activity, we need to provide a command called git branch, the branch which we want to create, the name of a branch which we want to create, space, and the source branch from which our actual branch needs to get created. Got it? See, if you want to create a branch, definitely you need to keep that particular branch reference towards the another branch. See here in our diagram also, if I want to create a development branch, I am taking a copy of main or a master branch, right? If I want to create a feature branches, I am taking a copy of development branch. That means I am making a references towards this particular development branch. That means I am already making a reference. I am not developing with an empty. I am already taking a copy of existing branch and I am making a changes there. For that particular activity, we will give git branch, the branch name, space, the reference branch name. That is a command. And if you want to check out towards a new branch after creating, git checkout -b and the respective branch name which needs to get created. Okay, clear?
Clear.
So do you have any note of comments so that
Yeah, I have that.
both
I have that. Once this topic is clear, once this particular portion is completed, I will provide you almost 25 plus 25 plus
comments are there?
working, yeah, 25 plus working commands are there, which is given with a detailed explanation what command will be used for what. Okay, so for easy, for making you easy, what I will do is I will send that particular file today itself, and after our session, reach out towards the institute after 10 minutes after completion of our session. Reach out towards the institute and take that git file. Okay, so that it will be easy for you. I'm just giving it today itself. Okay, generally I used to give once the completion of that particular topic. Let me give it to you today so that you will at least habituated towards that particular commands. What is a git init, what is a git checkouts and all that. Okay, and on today's any confusion on today's flow anywhere, please question me
No,
here.
but I have a doubt. Like the Studio app application, whatever is it just to convert the files into Git files?
It's not for the conversion, it is for us to make the files visual. Just for that, for example, see, if I am not going to use this particular Visual Studio code, I'm just closing this, then I need to use either a git command control or
Okay.
git related tool will be there. Okay, I need to use any of that command tools, and I need to make, or I need to create a files, and then I need to go towards that particular directory. Let me go towards this particular VRIT. Now see, in this is my repository. In this particular repository, I need to create a new file. Let me go and give it here. See here, there is a bitmap image or rich text document or a text document, something like this. Very short selections was there, but in our IDEs, not a Visual Studio, we had a lot more. Eclipse, Visual Studio, or PyCharm, any of the IDE is fine. So those particular IDEs will be used for us to create n different types of files instead of these bitmap image or rich text file. For example, I am just going with this rich text document. See what this is, right? For example, if I want to create something like a Python file, let me go and give it. See, this is a text document, not a Python file. For example, test.py, I'm just giving like this. See, this is a test.py file, but it extended with the type called text document. So this is not a Python file, right? That is the reason. Instead of that only, we will be using one of an IDE, the development tool, only for that particular activities. To generate n different types of files, we will be using a IDEs. But if your local machine automatically gives you n different types of files here, no need of IDE. You can directly go and, for example, this particular file I have created, I will just open this particular file. See, this is directly opening in the Visual Studio. Instead of that, I will just open this particular test.py, which generally created. So you can open it in any type. I'm just going with the notepad. Okay, so opening this, I'm just entering some data, saving it. See, control S I'm giving, that's it. Closing it, refresh. See, earlier it is a 0 KB, now it is having certain data. See, now it is having certain data, right? So only for that tracking purpose and to make us feel that okay, something was happening towards a file, some changes are coming towards a file. These are the changes that we are have done towards the file. Only for the tracking purpose we will be doing IDEs.
Only for
And
our reference.
don't, for our references, to make our job more easy, to create n different types of a files. Instead of creating text document every time, sometimes you need to create a Python file, sometimes Java file, sometimes .NET. So you need to create n different types of a files, right? If you are having in your local mission, if you are having that particular opportunity here, so you no need to use that IDEs, but we generally don't have that particular opportunities, right? That is the reason we will stick to one of an IDE. So for ease of doing, instead of making a dependent, so I will use Visual Studio Code. You people use something like PyCharm or Visual Studio or Eclipse. Any of that is fine. Anything is fine. So we will see different tools, how different tools will perform the repositories. Same, the commands will be the same across all the tools. Even at the command line interfaces also, the commands will be the same. No changes in the commands. Only the changes, just the UI. I am using Visual Studio Code. You will use some PyCharm or some other will use something like an Eclipse, right? Only for our visualization, which is better, we can download that and use that. Okay, clear?
Yeah.